Now see, if we want to explain the motion in a plane, then we already discussed this thing. We must have position vector, and then with the help of that, we have to prepare the displacement vector. So now position vector and displacement in Cartesian component form first. See, here the position vector that we represent by vector r. Here, as shown in the figure, suppose position of point P is represented by this position vector r. Now, if we draw normal from P to x-axis, that is Pm, and P to y-axis, that is PQ, then suppose OM, that is x, and OQ, that is y, then we can write vector OM, that is magnitude of vector OM into I caret, because it is in x direction, but magnitude of OM is taken as x. So we can write vector OM, that is xi caret. Similarly, we can write vector MP, that is equal to yj caret. Now from figure we can write vector OP, that is vector OM plus vector MP as vector summation rule. So vector R, that is equal to xi plus yj. Now if we have x and y, then we can calculate the magnitude of this position vector R. So R, that is under root x square plus y square. And the direction of this position vector, that is tan theta, that is opposite upon adjacent, that is y by x. This position vector is represented here in component form in 2 dimensions. In 3 dimensions, we can write position vector R, that is xi caret plus yj caret plus zk caret, and its magnitude, that is under root x square plus y square plus z square. So in this way, one can represent the position vector in component form. Now displacement vector. Okay. Now suppose we consider the position of the particle, which one is moving on the curved path in xy plane as shown in the figure, is at point P at time t1, and its position vector at time t1, that is vector r. Then at some time t2, that particle is at point q. The position vector of particle at time t2, that is r dash. Suppose coordinates of point P are x and y, and coordinates of point Q are x dash and y dash. Now vector OP, this vector OP, that is vector R, is position at time t1. Vector OQ, that is vector R dash, that is position at time t2. So we can write in component form position vector R, that is xi caret plus yj caret. Vector R dash, that is x dash I caret plus y dash j caret. So delta R, change in position, that is P2Q. Say that vector is delta R. So delta R, that is final position minus initial position. So vector R dash minus vector R. Vector R dash, that is x dash I caret plus y dash j caret minus xi caret plus yj caret. Now delta R, that we can write x dash minus x into I caret plus y dash minus y into j caret. So change in x coordinate is represented by delta x and change in y coordinate is represented by delta y. So delta r, that is delta x I caret plus delta y j caret, where delta r, that is the displacement of particle in time interval t2 minus t1. Clear to all of you? This is the concept of a position vector. Change in position means displacement of the particle in the given time interval.